Okay, now let's begin, okay? So here, now let's see an example. In each part, confirm that the limit is an indeterminate form of cap infinity by infinity, okay? Infinity by infinity, and apply the L'Hopital's rule. So number A is limit x approaches 0 from right. Ln x divided cosecant x. The second is x approaches plus infinity x by ex, okay? By ex. Here is x squared by e to the power x. And here is x cubed by e to the x power, okay? And here is x to the nth power. And this is ex by x to the nth power, okay? So the first one, here, number A, okay? Here is the first limit x approaches 0 from left, or from right. From right, ln x approaches what? This one approaches what? So first you must remember the figure, okay? The picture of ln x. The picture of ln x actually is like this. Here is ln 1 is 0, so here is the past 1, 0, this point. This point is 1, 0, so actually here is the picture, yes, the picture of ln x. So here we can see where x approaches 0 from right. So this is go to minus infinity, okay? Go to minus infinity. So here actually is minus infinity, yeah? Minus infinity. And here limit x approaches 0 from right. Cosecant x approaches what? Cosecant x actually is 1 by sin x, yeah? 1 by sin x. So here actually is the limit x approaches 0 from right. 1 by sin x. Sin x actually is sin x approaches 0, sin x approaches 0. 1 by 0. So actually here is what? Is plus infinity, yeah? So here is minus infinity by plus infinity, so it's infinity by infinity, yeah?
Yeah.
Infinity by infinity, so here we can use the L'Hopital's rule. The L'Hopital's rule, so here this limit actually equal to limit x approaches 0 from right. Ln x divided cosecant x. This limit equal to limit x approaches 0 from right. So ln x prime divided cosecant x prime. Yeah? Ln x prime is what? Here is x approaches 0 from right. Ln x prime actually is 1 by x. So here cosecant x prime is what? It's cosecant x minus cosecant x times cosecant x. Yeah? Cosecant x times minus here. So here actually is limit x approaches 0 from right. Here is 1 by minus x. Here x put it in here. Cosecant x actually is what? Is 1 by sin x. Yes. So 1 by sin x times cosecant x actually is what? Cosecant x actually is cosine x divided sin x. Yeah. So here we can see here actually is here is equal to here minus put it out. Here minus but here. So minus limit x approaches 0 from right. So here actually is sin x divided x times what? Times here actually is sin x divided cosine x. So this limit x approaches 0, this limit is 1, yeah? This limit is sin 0 divided by cosine 0. Sin 0 is 0, cosine 0 is 1. So it's 0 by 1. So here is minus 1, this part is 1. 1 times this part is 0, this part is 1. So here is 0. Yeah, 0. So this is the first one. Now for the second, here, second is x by ex. Okay, x by ex. So first here, x approaches plus infinity. X actually this is plus infinity, and x approaches plus infinity ex. Of course, this is plus infinity. Yeah. So infinity by infinity. So here this is indeterminate form of type infinity by infinity. So we can use the L'Hopital's rule. So x approaches plus infinity. Here is x by ex. So we use the L'Hopital's rule. So here is the limit x approaches plus infinity x prime divided by ex prime. Yeah?
Yeah.
So x prime is 1. Ex prime is ex. So here is the limit x approaches plus infinity. 1 divided ex. Ex approaches what? X approaches plus infinity. Ex approaches infinity. 1 by infinity? 0. So here is 0. Yeah? Here 0. So this is the number B. So number C, here is x squared, here is the same. So here we can see when x approaches plus infinity, x squared also approaches plus infinity. Yeah? Also approaches plus infinity. So here, so this limit is infinity by infinity. So we use the L'Hopital's rule. So here is limit x approaches plus infinity x squared by ex. Infinity by infinity. So equal to limit x approaches plus infinity, x squared plus by ex plus, yeah? So here is equal to what? So x squared plus is 2x by ex, so here equal to this limit. Yeah, this limit. So this is 2, it's a constant. This constant can move it to outside, yeah? So this is equal to this limit. This limit, now we can see x approaches plus infinity, this approaches plus infinity. This is also plus infinity. So plus infinity, so here is also an indeterminate form. So we can use the L'Hopital's rule again. We can use the L'Hopital's rule again. So here equal to what? Equal to 2 times limit x approaches plus infinity, x prime divided ex prime. So x prime is what? X prime is 2 limit. So x prime here is 1 by ex. X approaches plus infinity. So here is 1 plus, here is what? Ex. X approaches plus infinity. So infinity, 1 by infinity. So 0, yeah? So 0. So 0. So here, now, if here is so number d, okay? Number d, x cubed. X cubed. So if here is x cubed, so if here is x cubed, if here is x cubed, where x approaches plus infinity, x cubed approaches plus infinity, yeah? This is plus infinity. So infinity by infinity. So the L'Hopital's rule, so here is what? Is x cubed prime, yeah? So ex prime. So x cubed prime is what? Here actually here should be 3x squared, yeah? X cubed prime. So 3x squared, yeah? 3x squared here is ex, yeah? So here 3 is a constant. This constant can move out. So here is 3. So here is x squared. X squared, x approaches plus infinity, x squared plus infinity. Ex plus infinity. So infinity by infinity. So here is also an indeterminate form of infinity by infinity. So here we use what? We use the L'Hopital's rule again. So here is what? Here is 3. Here is what? Here is 2x. Yeah? So this 2 move out. So here 6. So here is ex. Here is ex. So x by ex. X by ex, they are the same. Yeah? So infinity by infinity. So indeterminate form. So here this limit is equal to 6. Limit x approaches plus infinity. Here is 1 by ex. So here equal to 0. So here means what? Here 0, 0, 0. So here then when the power is 1, 0. When the power is 2, 0. When the power is 3, the limit is 0. When the power is n, 0. So what's the limit? 0. So actually it's also 0, okay? It's also 0. So here actually it's the same, okay? It's the same. We can see here limit x approaches plus infinity, x to the nth power divided by ex. This limit, okay? This limit equal to what? This limit equal to, here is infinity. So use the L'Hopital's rule. Here is x approaches plus infinity. Here is x nth power prime. Nth power prime is n x n minus 1, yeah? Divided by ex prime, yeah? Ex prime is ex. So here we use once L'Hopital's rule. So here x approaches plus infinity, this part approaches what? Plus infinity, yeah? So here is plus infinity. So infinity by infinity. So we can use the L'Hopital's rule again. So here is again limit equal to what? Equal to limit x approaches plus infinity, this prime. So here is n times n minus 1 x minus 2 divided ex. Yeah? So we use the second, we use twice. Okay, we use L'Hopital's rule twice. So we, here. So you can use again. So here to here, limit x approaches plus infinity, n times n minus 1 times n minus 2 equals to 2 times 1 times x to the 0 divided ex. So here we use what? We use n times, or we use the L'Hopital's rule n times. So we can do here. So x to the 0 power is 1. So here for a fixed n, this is a constant. Yeah. If n is fixed, for example, n is equal to 5. So here this is a constant. Yeah. The numerator is a constant, but ex approaches infinity. So a constant divided by infinity is 0. Yeah. Is 0. So here means what? Here means x approaches plus infinity x to the nth power divided by ex. Here is approaches 0. So here pair in fact, or so here pair effect. Okay. Here are the effects. Here means what? Here means what? Limit x approaches plus infinity x to the nth power. This limit is plus infinity, and limit x approaches plus infinity ex also approaches plus infinity, and what? And limit x approaches plus infinity x to the nth power divided ex. This limit is 0. So this three limit, here are the effect. When x approaches plus infinity, the function x to the nth power is close, okay, close to plus infinity. Yeah, the function x to the nth power close to plus infinity, and the function ex also close to plus infinity. But these two functions, who is fast, who is slow, who is fast to plus infinity, who is slow to plus infinity. So here actually we have, because here we use this conclusion, means what? Means here this ex close fast and x to n close slow. Okay, close slow. So here we have this and ex eventually close more repeatedly than any positive integer power of x. So here we have this result. Okay, we have this result. Where x approaches plus infinity plus infinity, the function x to the nth power goes to plus infinity, and the function ex goes to plus infinity, but ex eventually grows more repeatedly than any positive integer power of x. So here means what? Here means when x approaches plus infinity, so growth speed, okay, the growth speed is we have what? Ex greater than x to the nth power, okay? The speed, okay, the speed. When x approaches plus infinity, the growth speed Ex greater than x to the nth power, okay? So now we do an access, okay? So we do an access for this limit ln x divided x squared when x approaches plus infinity. So now we do this access, okay? This access. Limit x approaches plus infinity ln x divided by x squared. So now do this access. No, I think it's easy, yeah? So here first, okay, the first step, you must confirm it infinity by infinity form. Yeah, so here we can see limit x approaches plus infinity ln x approaches what? Approaches plus infinity, yeah? The limit x approaches plus infinity, x square approaches what? Plus infinity, yeah? So infinity by infinity. So indeterminate form of type infinity by infinity. So here we can use the L'Hopital's rule. So here equal to limit x approaches plus infinity ln x prime divided x square prime. So here is the limit x approaches plus infinity. Here is the ln x prime is what? Is 1 by x square prime is 2x. Yeah. So here is the limit x approaches plus infinity. Here is 1 by 2x square. Yeah. X approaches plus infinity. 2x square approaches what? Plus infinity. Yeah. So here is 1 by plus infinity is what? 0. Yeah. 0. So here we have a question. If here is x cubed, if here is x cubed, it's the same, yeah? It is the same. If here is x cubed, actually here is x cubed. So here is a cube. So here is 3x square, yeah? 3x square. So here is 3x cubed, yeah? X cubed here is also 0, yeah? So here is if here is the fourth power, the same, yeah. 5 power the same. So if here is nth power, so here if here is nth power, here is x to the nth power. Here is n x n minus 1. So here is n x to the nth power. Of course here n is greater than 0. So here is also 0, yeah. So here means what? Here means now. So this example here asks a fact. When x approaches plus infinity, ln x grows to infinity, x to the nth power grows to the infinity. But who is fast? Who is slow? These two. Who is fast? Who is slow? So here is slow, here is fast. Yeah, the fast. So here we have this conclusion. Here is greater than ln x. Okay. So when x approaches plus infinity, the growth speed ex greater than x to the nth power, x nth power greater than ln x. Here n is positive, okay? Here n is positive. So we have this conclusion, okay? So this result, okay? This result, I think that you must keep in mind, okay? Keep in mind. So here, if you keep this in mind, so here, for example, ex ln x limit x approaches plus infinity. This is equal to what? This is fast. This is slow. Yeah. So here is plus infinity. Okay. So here is the second. Okay. Here is the second indeterminate form. So here we have the third. So now we have started these two indeterminate forms, okay? 0 by 0, infinity by infinity. So actually we have the third, okay? We have the third, for example, for this limit. Limit x approaches 0 from right. X times ln x. X times ln x. Now let's see this limit, okay? This limit. We can see this limit actually is what? X, when x approaches 0 from right. X, this limit is 0, yeah? 0. And the limit x approaches 0 from right. Ln x, this limit is what? Is minus infinity, yeah? So here actually there is 0 times infinity, okay? So 0 times infinity, 0 times infinity, okay? So here this part is also an indeterminate form, okay? 0 times infinity, 0 times infinity. So here this is actually is what? Is for this limit x approaches a fx. This limit is equal to 0, and the limit x approaches a gx. This limit is equal to infinity. So what about this limit? What about this limit? X approaches a fx times gx. So what about this limit? So what about this limit? So here. So what about this limit? This is also indeterminate form. Okay. So actually, for this indeterminate form, actually we can transform it. Okay. We transform it. For you can see here, 0 times infinity. We can rewrite it. 0 actually we can write it by 1 by infinity. Yeah. 0 equal to 1 by infinity times infinity, yeah? So actually here is infinity by infinity, yeah? So we can transform, okay? We can transform 0 times infinity by infinity. Or we can do what? Or we can do 0 times infinity. We can rewrite this infinity by 1 by 0. Infinity equal to 1 by 0. So 0 times infinity equal to 0 times 1 by 0. So here is 0 by 0. So here means what? Here means we can rewrite this form. Okay? We can rewrite this form. We can transfer it into the first or the second. Okay? The first or the second. So for example, for this one, so here we can see this limit, okay? This limit. So this limit is equal to what? Equal to limit x approaches 0 from right. We can rewrite x. We can rewrite x by what? By ln x. 1 by x. Yeah? We can rewrite it here in this form, yeah? Yeah. Because x we can rewrite it by 1 by x. Yeah? X equal to 1 by x. Yes. So here we can see we can rewrite it in this form. Okay? Or we can write it in another form, okay? Because here ln x we can rewrite it in by 1 by ln x. So here actually we can another form, okay? Another form is equal to limit x approaches 1 plus r from right. So here is here is x by 1 by ln x. Yeah? So they are the same, yeah? The first here is infinity by infinity. This form is 0 by 0. So we can choose this, okay, choose this. So choose which one? So choose which one? So actually, the derivative, which derivative is easy, we choose which one. So you can see here, this part, this derivative is not easy, so we do not choose this one. So we choose this one, okay? We choose the first one. So choose the first one here. X approaches 0 from right. So here ln x actually is infinity. This is infinity, so infinity by infinity. So we use the L'Hopital's rule. So here is the limit x approaches 0 from right. Ln x derivative is 1 by x. Yeah? Ln x derivative.
Yes.
1 by x. Yeah? 1 by x derivative is what? 1 by x derivative. 1 by x actually is x minus 1 power derivative. Yeah? So here is what? Here is minus 1x minus 1 minus 1. So minus x minus 2. Yeah? So here is what? Here is minus x minus 2. Yeah? So equal to here? Equal to here? You understand? Yeah?
So repeat.
So here, so from here to here, I just rewrite x by x equal to 1 by 1 by x. X equal to 1 by 1 by x. So from this step to here, we just rewrite x by 1 by 1 by x. So here x times ln x equal to ln x by 1 by x. So equal to here. Equal to here, and so here we can see this is infinity, this is infinity, so infinity by infinity. So we use the L'Hopital's rule. So here equal to limit x approaches 0 and right. This derivative, ln x derivative is what? Is 1 by x. 1 by x derivative is minus x minus 2 power. Yeah? So here equal to this. So here actually is what? So we times x square on both sides. We times x square on both sides. So here is limit x approaches 0 from right. So here we times x square. So here is 1 by x times x square. Here is minus x minus 2 times x square. Yeah? So here is what? So here is, you can see here is limit x approaches 0 from right. X 1 by x times x square, here is what? Here is x, yes? X minus 2 times x square is 1. Minus, so here is minus 1. Yeah? So the result actually is limit x approaches 0 from right. Minus x, yeah? Minus x, here is what? Here is 0, yeah? X approaches 0 minus x. Here it is minus, we can take it out, yeah? So here is what? Here is 0, yeah? So the result is 0. So here, I just want to tell you that for this form, for this 0 times infinity, 0 times infinity, we can transfer it. We can transfer it to 0 by 0 or infinity by infinity. Okay? We can transfer it by 0 or infinity by infinity. And you choose which one. Determine which one the derivative is easy. You choose which one, okay? If this derivative is easy, so you choose this one. If this derivative is easy, you choose this one, okay? Yeah. So this is this derivative. Yeah.
I need turn off this mouth. It's become noise.
Here?
No, mouth is bigger. Mic. This one. I don't know.
Here?
Can you off the can you off the microphone?
So
Can you turn off the microphone?
turn off.
Yeah.
So how turn off? Oh, no.
লক করে দাও, লক করে দাও।
So I'm so sorry. I don't know how to come out. So after class, okay? So now, so this is the third indeterminate form, okay? Now we have the force indeterminate. So for this one, okay, for this. This means this form, infinity minus infinity, okay, minus infinity, infinity minus infinity. So here for this, infinity minus infinity. So here this one, okay, infinity minus infinity or infinity plus infinity, okay, plus infinity or minus infinity for this. So here now we can see infinity plus infinity, okay? Here this infinity can be plus infinity, minus infinity. This infinity can be plus infinity, minus infinity. So here we have two choose. So we have four, okay? So firstly is plus infinity, plus infinity. The second is plus infinity, plus minus infinity, okay? So the third is minus infinity plus infinity and minus infinity plus minus infinity, okay? So we have this form, okay? And here infinity minus infinity, okay? Infinity minus infinity for this one. Here the first is can be plus infinity or minus infinity. Here is plus infinity or minus infinity. So here we have two choose. Here two choose. 2 times 2. So here we have 4. We have 4. The first thing is plus infinity minus plus infinity. Or plus infinity minus infinity. Or minus infinity minus plus infinity. Or minus infinity minus infinity. So here we have 4. Here this 4. So we have 8. So here for the first one here. Plus infinity plus infinity. So here is what? Plus infinity plus infinity. So this means what? Plus infinity plus infinity. So you what? Is a plus infinity, yeah? So here is plus infinity. So here plus infinity plus minus infinity.
Plus infinity.
No. Sometimes it can be plus infinity, sometimes it can be a 0, sometimes it can be a constant. For example, you can see x limit x approaches plus infinity, x in here x plus minus x. So here you can see here this is plus infinity, yeah? This is minus infinity, yeah? So plus infinity plus minus infinity. So here 0, yeah? So this case is 0, yeah? But you can see here limit x approaches plus infinity. If here is 2x plus minus x, 2x plus infinity, yeah? This is minus infinity. Plus infinity plus minus infinity. So here is what? 2x plus minus x. So here is x. So here is what? Plus infinity, yeah? So here, for example, for this example, x approaches plus infinity. Here is x minus or plus minus 2x. So here is, you can see here is plus infinity, here is minus infinity. So here is plus infinity plus minus infinity. So here is what? Minus infinity. Yeah. So you can see sometimes it is plus infinity, sometimes it's minus infinity, sometimes it's 0. So here for this case, actually it's indeterminate. Indeterminate. This is indeterminate. So here actually this case, okay, they are the same, yeah. The third and the second, they are the same, yeah. You can see, we can see a plus b equal to b plus a, yeah. So they are the same. So here this case is also indeterminate. Now, and for this one, minus infinity plus minus infinity. So this one is minus infinity, yeah? Even they are the same, yeah, they are the same. You can see they are the same class. So here is the minus infinity, yeah? So here for this first we have two indeterminate. Now for this one is what? Plus infinity minus plus infinity. So here is you can see here, okay, this one. For example, limit x approaches plus infinity. Here is 2x minus x. X approaches plus infinity. This one plus infinity. This is plus infinity. Plus infinity minus plus infinity. Yeah. So this is what? This is plus infinity. Yeah. But if here limit x approaches plus infinity, here is x minus 2x. This is plus infinity. This is plus infinity. So here is what? The minus infinity. Yeah. And the limit x approaches plus infinity, x minus x, plus infinity. So here is what? 0. Yeah. So this one is what? Indeterminate. Yeah, indeterminate. So what about this one? This one, okay? Here, now. Plus infinity minus infinity. Minus infinity is what? Plus. So here actually is what? Here actually is plus infinity plus infinity, yeah? Yeah, because here minus, so plus. So here is plus infinity, so equal to what? Plus infinity, yeah? And this one is minus plus infinity. So here this one actually is here is minus infinity. So here we can see here is minus infinity. Minus we can write it by plus minus infinity. Yeah. Minus because because b minus a equal to b plus minus a. Yeah. So here plus minus. So here is minus infinity. Yeah. And for the last one, here, the last one, actually here, this one, you can see is limit x approaches plus infinity minus x minus 2x. You can see here is minus infinity, here minus infinity, yeah? So here this result is what? Here is minus x plus 2x, so here is x, so plus infinity, yeah? And here, x approaches plus infinity. So here is what? Here is minus 2x minus x. So you can see here, minus infinity. So minus infinity minus infinity. So here is minus 2x plus x. So here is minus x. So here is minus infinity. Yeah? So plus infinity minus infinity. So this case actually is indeterminate. So for this case, for this four case, okay, these two and these, okay, this form is also indeterminate form. So what about this four indeterminate form? How to find the limit? So have a lunch, okay, have a lunch.